Hello and welcome to today's video on Modo's new Curve Boolean tool. In 3D modelling, a Boolean is an operation that allows you to intersect, subtract or union two pieces of 3D polygonal mesh. The Curve Boolean tool allows you to create complex 2D shapes using curve tools, and then create a system of Booleans to subtract, union, intersect or slice the curves before converting them into complex 3D models. Working with curve Booleans is great for creating complex shapes or designs such as logos or patterns. There are four Boolean operations within the curve Boolean system: slice, union, intersect, or subtract. Slice allows you to overlap multiple curves and create new control points where the curves intersect. Union allows you to merge multiple overlapping curves into one shape and then removes any overlapping curve segments. Intersect allows you to overlap two curves and then deletes anything that exists outside of the overlap. And subtract allows you to use a curve to remove segments or another curve and can be used to cut out shapes from a base mesh. Now that we know what the Curve Boolean tool is and what it does, let's get to the tutorial. So, for this demo, I'll be using the new Curve Boolean system to model the Modo logo. The first thing that I'm going to do is set up my workspace. I want all of my curves to be totally flat on the ground plane so that nothing gets warped. To do this, I'm going to change my view to a top-down one by holding down Ctrl and Space and then selecting Top. Then, I'm going to quickly drag and drop an image of the Modo logo into the scene so that I have a backdrop that I can use to trace the logo with my curves. Once that's in, I'm going to adjust the transparency so my curves are easy to see as I'm drawing them, and then right-click on the backdrop item in the items list and select Lock/Unlock to lock the backdrop. This is so I don't accidentally move it while I'm working. Once that's set up, I'm going to open up the Mesh Ops menu by pressing the Mesh Operations Viewport button above my 3D viewport and my workspace is set up. Now that everything's set up, I'm going to use the Curve tool available in the Create tab to start drawing the outline of the M. To create the curve, click along the side of the M to create points. As I draw out my curve, I might find that my points need to be repositioned or more points need to be added. To move points, all I need to do is click the point that I want to move and then drag it. To add more points, I need to select a point adjacent to where I want to add a new point and then click on the curve to create a new point. Now that I'm getting to the end of my curve, I want to make sure that the curve is closed so it's totally airtight and one solid shape. Any Boolean operations I apply will not work unless my curves are closed and totally airtight, so this is a very important step. To close the curve, I'm going to press the spacebar to open the Mini Properties window. I'm then going to click the Close checkbox to make sure that my curve is closed. When this checkbox is ticked, I'll see a new curve segment drawn between the first point I drew and the last point I drew. Once I'm happy with how everything looks, I'm going to press Q to drop the curve tool. Once I finish drawing my curves, I like to add a freeze mesh up by clicking the Add Operation button, typing in freeze and then double clicking the operation after it appears in the list. If you can't see your mesh once the freeze operation is put down, change your viewport setting from default to solid. The mesh produced by the freeze operation will now be visible. This helps me see my curve as a filled-in mesh and can help visualize any tweaks that I might need to make if my shape is off. Once everything looks good, I'm going to hide that freeze mesh up by clicking on the eye icon next to the operation in the Mesh Ops window. I'll be adding an extrude operation to my Mesh Ops stack later, so it's easier to just keep that one in my stack instead of deleting it and creating a new one later on. Now that we have our main shape drawn out, it's time to take a look at what details we want to create and what kind of Boolean we'll need to use to create them. So, for these smaller areas that break up the corners of the M, we'll only really need to create a couple of small curves and then subtract them. However, when looking at this question mark type shape and the stripes at the end of the M, I can foresee a bit more work. This stripe part looks like it needs to be a couple of curves that are joined together before they can be used to drive subtraction, while the question mark section has a shape within a shape, so would probably need a curve winding aligner operation to make sure that the right areas are cut out. Okay, I just mentioned that I'll probably need to use a curve winding aligner for that question mark bit. But what exactly is a curve winding aligner? Well, the curve winding aligner is a new mesh op that allows you to cut out a shape within a shape. But what does that mean? So, for example, there's a ring around the Modo logo. If we were direct modelling, we could probably just create a cylinder primitive, bevel the top, and then delete all the faces that aren't in the ring. However, we want to create this shape procedurally and with mesh ops. So to create this ring procedurally, it probably makes sense to just create two circle curves and then scale them so one sits inside another. Sounds great in theory, but once you add a freeze or a curve fill to generate polygons, we run into an issue. The centre isn't cut out. This is where the curve winding aligner comes in. The curve winding aligner is a smart little operation that basically picks up that there's a closed curve within a closed curve and then tells the freeze or curve fill to only fill between the two closed curves. So, if I quickly hide my curve fill and then add a curve winding aligner below it, when I turn the fill back on, you can see that my circle is no longer solid and I now have a ring. Now that we know what the curve winding aligner is and how it works, let me show you how it can be used on more complex shapes and how it interacts with curved booleans. After creating a new mesh item and naming it something easily identifiable, I'm going to draw the outline of the main bulk of the question mark. Starting at the bottom bit that exists outside of my M, I'm going to go all the way up and around and then back down to close the curve. To make those big sweeping curves, place down a starting point, and then when you place down a second point, hold down the left mouse button and drag. This causes the shape to go from a straight line to a smooth curve. This will also produce two handles that can be used to further manipulate the curve as you need. To create nice, sharp corners while using the Bezier curve tool, click and drag the handle outside of your curve and then make it shorter. The longer the handle is, the broader the curve, while the shorter the handle is, the straighter the curve. Once I have my outline drawn out, I'm going to reset the tool by holding down Shift and then click where I want my new curve to start. Once I've got a new curve set up, I'm going to get to drawing the inside of the shape. Once my inside and my outside are both drawn, I'm going to apply a curve winding aligner operation by clicking the Add Operation button in the Mesh Ops window, typing in Curve Winding Aligner, and then double-clicking the operation when it appears. Now that my curve is drawn and the aligner operation is applied, I'm going to show you how this is used as a driver mesh to create a subtraction boolean. Okay, so what's a driver mesh? Well, a driver mesh is a mesh that is used to create or drive the boolean. How do we do that though? So the first thing that we need to do is to create a curve boolean operation within the mesh item that contains our Modo M. Do this by selecting the mesh that contains your Modo M in the items list, and then add a curve boolean operation via the Add Operation button in the Mesh Ops window. Once that's created, we can set the question mark mesh as a driver for a subtraction boolean. There are two ways to do this. The first is to expand the curve boolean operation, click Add Driver Mesh, and then add the mesh you want. This is a fine way to add drivers, but if you ever are working with multiple drivers, I would recommend using the schematic viewport. To open up the schematic viewport, click the schematic viewport button underneath your 3D viewport. The schematic viewport is really handy for visualizing the relationships between your driver curves and your curve boolean operation, but is also hugely helpful if you ever need to troubleshoot as to why an operation may not be working the way you think it should be. Now that I can see the schematic viewport, I'm going to drag in the curve boolean from my logo mesh item, as well as the whole question mark mesh item. With both of those available to me in the schematic viewport, I can just plug the question mark mesh into the driver mesh channel of the curve boolean operation. Once plugged in, double click the boolean node and change the operation from slice to subtract. Once that operation is set to subtract, you should actually now be able to see that any curve segments that overlap with our aligner mesh are now gone. Now that my operation has been applied, I'm going to really quickly close the schematic viewport so that my 3D viewport is maximised. I'm now just going to really quickly unhide that freeze operation from earlier and apply a polygon extrude operation, and then extrude by 1 meter in the y-axis to make sure that my mesh has been subtracted properly. I'm also going to switch back over to the perspective view by holding down the space button and control and then selecting perspective, just to make sure that everything looks alright at all angles. A really cool thing about working with mesh operations, or procedural models in general, is that as I add more drivers to my curve Boolean operation, that freeze and extrude will automatically update. So this means that I don't have to delete those operations now and then reapply them later when I add more drivers to my curve Boolean. I just need to turn them back on and any edits that I make will be there. Now that I know that my operation is working nicely, I'm going to hide those freeze and extrude operations and then move on to making the other parts of the logo that need to be subtracted from my main mesh to make the Modo logo. So, moving on, I'm going to save the easiest part till last and show you how you can use a Boolean to drive a Boolean. I mentioned earlier that this part will probably need to be a couple of curves that are joined together and then used as a driver. We could probably make this whole shape in one go, but it's a lot quicker and easier to just make all these shapes individually and then use a union to create one compound shape. Okay, let's get started. First, create a new mesh item and name it something you'll remember. I'm going to call this Union Driver. Just like before, I'm going to draw out each of my curves with the Bezier curve tool. Whenever I want to create a new curve, I'm going to hold down Shift on my keyboard and then click where I want my new curve to start. Don't forget to make sure that before you move on to making a new curve, the previous curve is closed. Once all your curves are put down, apply another curve Boolean and change subtract to union. Enable merge curves to make sure that our curve is airtight and one shape. All the areas where the curves overlap are now gone and we have one big airtight curve. Just like with the winding aligner mesh, I'm going to quickly apply a freeze operation just to make sure that everything looks right. Once I'm happy with how everything looks, I'm going to move on and draw the last round of curves that we need to create the Modo logo. Because I know that all my curves are going to be subtracted from the M, I find it easier to assemble everything once I have all my curves drawn out. But feel free to add your drivers to your Boolean as you go. The last part of the logo that we need to create are the sharp corner areas that break up the M. So just like with the other three shapes we've created, we're going to create another new mesh item and name it something sensible. Using the Bezier curve tool again, draw out the two curves, make sure that they're closed, and then press Q to drop the tool when you're done. Because these curves are so small, I'm not going to put down a freeze operation because I'm fairly confident that they're fine. Now that I have all of my curves drawn out, it's time to assemble everything. The first thing that I'm going to do is open the schematic viewport back up. Now that the schematic viewport is visible again, I'm going to drag my corner and my union curves into the schematic viewport and then plug them into the curve Boolean node. Now that everything is hooked up, I can unhide the freeze and extrude operations I made earlier. Once unhidden, the freeze and extrude operations will update automatically and you'll be left with a fully procedural model of the Modo logo. As you can see, the curve Boolean and the curve winding aligner operators are a pair of really powerful tools that are able to really speed up the process of creating complex designs while harnessing the power of curves. This has been an introduction to curve Booleans. For more information on curve Booleans, Modo, or any of the tools that I've used in this video, check out learn.foundry.com/Modo. Thanks for watching.